Hello, I'm Hannah Donnert with the Collaborative on Health and the Environment. Change is bringing the latest environmental health science through our partnerships, calls, webinars, science serves, publications, and social media. I would like to welcome everyone to today's CHE EDC Strategies Partnership webinar, which is titled How Plastics Poison the Circular Economy. Data from China, Indonesia, Russia, and other countries reveal plastics public health threats. Our moderator today is Sarah Howard, founder and manager of diabetesandenvironment.org. We will leave time following the speakers' presentations for a brief Q&A session. You may type in questions through the Q&A feature available on the menu bar at the top of your window at any point during the presentation. For those who have called in on the phone, we have posted slides to accompany today's webinar on our website. You can download these by going to healthandenvironment.org. Please scroll to the bottom of the page and select today's webinar. On the webinar page is a link to the slides. Everyone on our webinar right now is muted with the exception of our speakers and moderator. This webinar is scheduled to last for 45 minutes and is being recorded for our call and webinar archive. With that, I'll turn things over to you, Sarah.
Thank you, Hannah. Thank you, everyone, for joining us. So we have two speakers today. Both are from IPEN, which is the International Pollutants Elimination Network. IPEN's a global network of over 600 nonprofit organizations from 128 countries that work to reduce the use of toxic chemicals. And we're going to hear about IPEN's new studies regarding toxic chemicals in consumer products from around the world. So our speakers are also going to discuss the policy implications of chemicals in plastics, the implications for a circular economy where products are reused or recycled, and also the new global plastic treaty. So our first speaker is Jitka Strakova, a researcher who has worked for 15 years with IPEN and Arnica, which is a Czech-based nonprofit organization. She conducts studies on persistent organic pollutants in products, waste, and the environment, and has authored many studies on this topic. Our second speaker will be Vito Buonsante, an environmental lawyer and policy advisor at IPEN. He has over 17 years of experience working on drafting, analyzing, and implementing chemical legislation in the European Union and internationally. He lives in Hamilton, Ontario, in Canada, and teaches at McMaster University. So we will have time for questions after both speakers speak, and you can type them anytime into the Q&A box, and I will moderate that at the end of both speakers. All right, Jitka, would you like to begin?
Sure. Thank you very much, Sarah, for your kind introduction. So good morning, good afternoon, or even good evening, everybody, depending on what part of globe you are joining us. As we all know, day by day, there is more and more evidence about the harms caused by plastic. Not only harms caused by plastic pollution itself, but also caused by toxic additives used in different plastic materials. Those plastic additives are not bound to polymeric structures and can quite commonly be emitted, released, can migrate from the plastic materials. Our recent studies adds to existing concerns, but not only concerns, but also arguments for urgent actions that stop circulation of toxic additives in plastic materials, consumer products, waste, and our environment. And with this, I would like to introduce you into three of our recent reports that were targeted into investigation of three different plastic additives present at the global markets of China, Indonesia, and Russia. Although we will talk here about three different plastic or synthetic consumer products and three different groups of chemicals, all three of our surveys have many common features. First of such common feature is that all three groups of chemicals are basically omnipresent. We find them in women breast milk, in urine, We find them in our drinking water. We find them far from the place of their origin, somewhere in Arctic. They are basically present and exposing humans and wildlife on a daily basis. Second, all those chemicals have negative adverse health effects. All negatively influence human hormonal system. They are known to be endocrine disrupting chemicals. And third, last but not least, many of those chemicals are already globally banned or nationally restricted, but many representatives of the same groups of chemicals are widely used and are regrettable substitutes of globally banned ones. The common feature of plastic additives is that once they enter the life cycle of plastic material, they continue to be released out. It's at the stage of plastic material or consumer product production, manufacturing, but also during consumer product use, recycling of secondary materials, at the moment when the waste and end-of-life products are being disposed, and in some cases even being exported into developing countries or into countries with economies in transitions. Additives cause harms when they are being incinerated or landfilled, as you will see in one of my next slides. They continue to expose humans also when they are recycled into new products and coming back to our homes. In here, I will dive into first of our recent survey. This one is about per and polyfluoroalkyl chemicals called as PFAS or forever chemicals. Forever because they are made of one of the strongest chemical bond made of carbon and fluorine, which makes them very difficult to be decomposed under natural conditions. This chemical bond and many other physical and chemical properties made PFAS circulate into environment for hundreds or even thousands of years. PFAS are used in products to make them water and grease resistant, but none of those properties is essential for the society. Contrary to that, there are many studies suggesting that PFAS may cause different health troubles, including impacts on hormonal system, reproductive functions. They can increase risk of different cancers. And unfortunately, it is our drinking water and human diet which is established as the main exposure route to PFAS. But there are also other exposure routes from our house dust, basically in the indoor environment, personal care products, and much more that relate and add to the main exposure routes. In our survey, we investigated presence of PFAS in outdoor clothing, mainly winter gloves, but not only gloves, but also t-shirts, sport trousers, or hijab used to cover head of women in Islamic countries. PFAS in those products are used to make them water resistant, as was mentioned earlier. And in our research, we tested 55 different PFAS compounds in 25 items of outdoor clothes. Even though PFAS are a very large group of chemicals counting several thousands of polymeric and non-polymeric compounds, we were able to test only 55 of them. It has very pragmatic reason. There are analytic standards available only for those around 50, 60 ones. And with those analytic limitations, there stay a lot of PFAS uncovered. Out of the 55 analyzed PFAS, 4 were identified in our group of products. From the data, we can also suggest that there is polymeric PFAS used, and these are side chain fluorotelomere-based polymers. With the analytic methods used in our research, we can't identify what individual polymers are used in those products, but with the presence of fluorotelomere alcohols, we can conclude that there are this type of fluorotelomere polymers used. With these findings, we can also conclude that there are some additional concerns about the presence and release of PFOA out of those products, because fluorotelomere-based side chain polymers can degrade into PFOA. PFOA, as you may know, is a chemical listed for global elimination by the Stockholm Convention, because PFOA is known to be very persistent, toxic, and accumulative. It's not only textile product and outdoor clothes what is treated by PFAS, but there are many more products in our house and in our surrounding being treated by PFAS. Those are fast food packaging, but for example, also firefighting foams and cosmetic products and much more. And this very broad use of PFAS made them present also in our environment and mainly in the waters. Once PFAS enters the environment, they continue to circulate because at the present times, we don't have technologies in use to treat, capture, and destruct PFAS emitted into our wastewaters. With this slide, I will slowly move to the topic of second group of chemicals, but some of the points I said for PFAS could be repeated because brominated flame retardants are also very broad group of chemicals with some legacy PFAS, with some legacy chemicals, and with some regrettable substitutes. With brominated flame retardants, we are able to demonstrate impact of another life cycle stage, and it is the moment when brominated flame retardant treated products are being recycled and used in production of new products. In our survey, we tested products made of black plastics that suggest that they come from e-waste and from the casings of TVs and other electronic equipment. With this research, we are able to illustrate that legacy PFAS originally used in electronic devices can be then transmitted into new products and arrive back to our homes. Unfortunately, the common practice is also to have e-waste from developed countries to be exported into African and Asian regions where basically communities suffer from e-waste dismantling practices that don't protect them against such a dangerous chemicals. We are quite common present in practices when e-waste is being burned on open fire or dismantled barefoot, bare hands, shredded without any protective equipment. The practice of brominated flame retardants recycling is not only illustrated in our recent studies for China, Indonesia, and Russia, but we found the same practice being present in the European Union countries and basically worldwide. We also have quite solid evidence about the impacts of e-waste imports into developing countries and contamination of food chain in the countries who basically receive the waste. When we look at the data we are presenting to you today, very concerning result is that all of our laboratory tested products, which were pre-screened by our simple X-ray device, contained at least one of the POP brominated flame retardants. Those brominated flame retardants with POP characteristics are called polybrominated diphenyl ethers. I use this abbreviation PBDEs. So BFRs basically have been found in consumer products even where fire resistance is not necessary, suggesting that the products are made from recycled plastic sourced from electronic waste. So basically, POP's recycling practice contaminates children's toys, products which are tend for sensitive part of the society. And with this conclusion, concerning an alarming conclusion, I am moving to last of our recent survey, which is into the presence of bisphenol A in baby feeding bottles. As you may know, bisphenol A is used as building block in polycarbonate plastics. And recent researches showed that it is 90% of world population having BPA in their bodies. And it's again children with, in particular, sensitive into the impact of BPA because it's endocrine disrupting chemical. It's again associated with reproductive harms in both men and human, many different neurological and brain effects, diabetes and obesity. And again, primary source for BPA is human diet, while air, dust, and water are other possible sources. And when we look at our data, from not only China, Indonesia, and Russia, but also several other Asian and African countries. In majority of tested baby feeding bottles was BPA identified above the limit of quantification. Very important finding is that also many of the products are mislabeled. Even though they show the label BPA free or containing 0% BPA, there are quantifiable levels of BPA detected by lab techniques. Some of the samples in the survey also violate existing legislations, and we can also illustrate quite some double standards in case of bottle which was manufactured in India, whereas there is some BPA legislation at place, and this sample wouldn't be complied with the legislation at place, but is being exported into Bhutan, into country lacking with an appropriate legislation. Important to say that in many countries surveyed in our research, there is currently no legal threshold and established, and basically no legislation restricting use of BPA in baby feeding bottles or any other type of product. And I'm almost approaching the end of my presentation. With this slide, I just wanted to highlight that already since 30 years ago, more than that, we have been bringing evidences about harmful effects of bisphenol A, and it took more than 20 years to be carried out before BPA was finally identified as endocrine disrupting chemical. Today, we are definitely getting more and more evidence about different regrettable substitutes of BPA, such as BPS and BPF, being used in polycarbonate and other plastics. So it took definitely far too long to make BPA restricted by some national legislation. And with this slide, I will hand over to my colleague Vito, who will talk more into detail into the legislation which may restrict or reduce use of plastic additives, but basically approaches promoted and suggested by IPEN are at first place using class-based approach for all three groups of discussed chemicals today. No use of regrettable substitute, which can be only achieved by class-based approach. Then we also work at the level of global incentives, Stockholm Basel Convention, or at the level of SAICOM. Because as you may see, there are different standards in different countries, and our markets are interlinked, and only with international global incentiveness we can arrange and establish the environment where toxic additives into plastics are not being exported into the countries lacking appropriate legislation. Definitely control need to be taken over the entire life cycle of plastic products, and including end of life and the moment when the products become waste. And there are definitely systematic solutions such as plastic treaty needed. And with this, I'm thanking for your kind attention, and Vito, floor is yours.
Great, thank you so much, Jitka. We'll be moving on in a moment to Vito's presentation, but I wanted to remind everyone while he's pulling up his slides to feel free to put in your questions in the Q&A feature, and we'll get to those after this last presentation. Looks like Vito, you're ready to go. Feel free to take the mic. Oh, Vito, I think you're muted.
I think so too. I was just looking for the button to unmute myself. So thank you very much. Thanks, Jitka, for introducing the data that we have provided. So what I'm going to talk about is like a bit more the, from a policy point of view, what happens now, since plastics have been in the forefront of the discussion in environmental policy. Like we're all aware of like the great amount of plastics that we have around, and also why we are highlighting the problems of chemicals, and in kind of a sort of alarmistic way, like this choice of like plastics as a poison to a circular economy, because chemicals may make a circular economy where materials are recycled over and over as problematic. So just to further introduce IPEN, where, for those that don't know us, we are a global network that has over 600 organizations in over 120 countries. And the main goal of IPEN is really to empower organizations and civil society in low and middle income countries, so that they are able to, so we are able to elevate their voices and bring them to the international arena and to various international fora. And also we try to provide data in these countries, which are often underrepresented in terms of like academic data, but also monitoring data. So what is the situation right now for global controls of plastics, like trying to shift a bit, and how chemicals come into this? Like, we have the Stockholm Convention that regulates persistent organic pollutants. But here, like, only some of those chemicals are relevant for plastics. And so that would mean, again, a chemical by chemical approach, not really a class-based approach. So it's a kind of a narrow approach. And the Basel Convention controls the shipment of plastics across borders, and the chemical concern are also sort of more of a harm reduction measure, like as it has mentioned, the problem of the POPs content in these plastics. Then we have the SAICM, which is like a sort of like a voluntary instrument that has like a broad scope, but very limited impacts because it's not legally binding. So now we come to the plastic treaty, and you may have heard the fact that in March 2022, the UNEA, which is basically the United Nations Environment Assembly, so think about it as a world parliament for countries that talk about environment, and they make their commitments about the environment there. And so in this case, if you look at the title of the resolution, it's called "End Plastic Pollution Towards an International Legally Binding Instrument." It is significant because there is a clear political will showed especially by many plastic producers, including the US, China, India, Indonesia, and the European Union, to start discussing on how we can solve the problem of plastics. So just to give you some top lines on what is included in this resolution. And again, this is not already a treaty, but it's a commitment to negotiate a treaty. And so the commitment is to have an agreement that should be legally binding, but that means also including both voluntarily and binding provisions. So far, the objective of the instrument has not been defined, and so it will be defined later. So will it be only about litter, or will it look also at the health impacts of plastics, or will it look at plastics in a more broader way? It surely has a commitment to achieve or to promote sustainable production and consumption, which is in line with Sustainable Development Goals. But more specifically, to be achieved through design and circular economy approaches, and to provide scientific and economic assessments. And so here also there's a commitment to a certain flexibility and to use science and an interface between science and policy to inform the future legal instrument. Again, so being a very broad commitment, there are many battlegrounds still. some of you may have heard of a paper that was published on Science a few days ago of a number of scientists calling for capping production on plastics, because that is the most, probably the most simple way to decrease the both environmental and health impacts of plastics. There is the issue of chemicals that does not appear at all, the word chemicals or additives, in the final text of the resolution. And there was also attempts to sort of eliminate even the word health, or the fact that plastic may have health impacts from the resolution. Then there's the issues: who's going to pay for the treaty? Is it going to be taxpayer money financing waste management that the plastic producer are not willing to take responsibility for? And then a framing issue from my side is like, are we talking about plastic products or plastic materials? There is clearly a concern about packaging, about single-use plastics, because it creates a lot of litter, but we also are aware of how many chemicals are used in plastics that are used in our everyday lives, in our homes, and for flooring. Like if we think about PVC, the uses are infinite, and the exposures are great, and there are problematic plastics there. So talking about material may make more sense than talking about products specifically. So one first thing that, and sorry for the very packed slide in text, is like, it is unclear if people, when they think about plastic, they think about really what plastic is. I'm not going to go read through these definitions, but these are 3 definitions of plastics that are found in legislation. The first is from the European Union. The second is from US federal law. And the third, sorry, I didn't put but it's from a recent Canadian order that includes plastic manufactured item, identified plastic manufactured items as toxic. And so the framing is slightly different. Like there's a framing around plastic being mainly polymers of different kinds, or being a mix of polymers and additives that are needed to give them a function. And what many don't know is that many plastics without chemical additives almost have no use. So there have been studies that have shown that there's about 10,000 different chemical substances that are used in plastics. But if we look more at the Canadian definition, it's more focused on the fact that plastic is basically a moldable material rather than at its intrinsic properties. And so increasing the understanding of what plastics are is important, and the role of IPEN is really to show how important is the role of chemicals in plastic, particularly toxic, hazardous chemicals. And these are the 3 technical reports that Jitka has just presented to you, but IPEN has a large number of many more reports around plastics and different aspects in the life cycle of plastics, from pellets, spills, and analysis of their content, to the chemical content of recycled plastic pellets, and to other ways, creative ways of disposing of plastics as plastic fuels, which creates other toxic impacts. So when we think about plastics, this graph gives like an idea of like how plastic production is going to increase in the next few years. But that increase in plastic goes hand in hand in increase of global chemical industry. You know, the chemical industry is the plastic industry. The plastic industry is the chemical industry. Like, so the petrochemical industry is here, and we're always talking about fossil fuels in the end. I'm just going to in the last part of this presentation just talk about how this resolution to end plastic pollution relates to chemicals and health, even if chemicals are not mentioned and even if health is not prominently featured in it. And this is a photo of like some of the group of IPEN leaders that were in Nairobi right after the resolution was adopted. So the first thing that I wanted to point out is the fact that despite a lot of pressure to make this resolution and a treaty about litter, there is a clear opening to the fact that plastic pollution includes all types of pollution, and it includes microplastics. And I put in brackets, even if it doesn't say so, that it includes chemicals, because once we talk about microplastic, we're talking also about the chemical components of microplastics, and also how microplastics have not only physical impacts, but also chemical impacts on the environment, on fauna, and on humans. So the fact that it's will look at all plastic pollution, it means that it should include also chemicals and the chemical impacts of plastic, not only the physical impacts. The second thing that is important to underline is that the commitment stresses that there should be a life cycle approach to plastic, to solving the plastic pollution issue. And this is important because it's not only looking at waste management. We're not only looking at what are we going to do with the plastic once it becomes waste, but like looking at the production, at the use, at the recycling, and the incineration. There is no clear understanding, common understanding among countries of where the life cycle of plastic starts. Is it from extraction? Is it from the creation of the chemicals that then are used to make plastic? Or it's just by the production of a product? So that is going to be something that will be discussed, but it also means that if we take a life cycle approach, we need to look at also the impact that chemicals have throughout the life cycle. And a very important one, and for us, and from where also the title of this series of reports come from, like a plastic poison, the circular economy, is that there is this push to solve the plastic issue by also changing the design of plastic, or by addressing plastic design, and by adopting circular economy approaches. And when we think about circular economy, we're both thinking about more durable material, less plastic being produced, but we're also talking about, you know, recirculating in the economy the materials as much as possible. And that is also the concern that we're trying to highlight, that if we circulate in the economy plastic containing, as the example of the recycled plastics of the study that Jitka talked about before, if we're talking about recycling brominated frame retardant plastics, and then we find them in toys or in kitchen utensils, that will be problematic. So we would want to advocate for a clean circular economy. And the fourth thing is the recognition that we need to address the health risk, and that health and well-being should be addressed, and its impacts on plastics, and those health risks are clearly presented by these chemicals. And here I put a cover of a publication that IPEN has done with the Endocrine Society that presents specifically I think 7 groups of chemicals that are more relevant to plastics and that cause a wide range of adverse health impacts. And so this is also an opening to how to better regulate plastics and regulate chemicals rather than going into a chemical to chemical approach. I'm going to end with like sort of a list of what we're looking for here, but the analysis is like looking at the opportunity, and now we need to look at what kind of solution we'll be able to get. So first of all, as many it is clearly understood by many, is that reducing plastic production is the most important way of reducing the health impacts and the environmental impacts of plastics, and also identifying essential uses. What uses do we really need, considering that we see plastic production be increasing more and more, especially as we transition from fossil fuels as a form of energy, away from fossil fuel as a form of energy, that those fossil fuels may be reused by creating more plastics. And going back to the materials, like we would want to see a restriction of some more problematic plastic, like polyvinyl chloride being one, fluorinated polymers being another, because they are not recyclable, they pose health risk, or polymers like polystyrene, which have like also toxic precursors. But again, also the transparency of the plastic ingredients is something we've been talking for a long time for all products, but here for plastics. And again, stop toxic recycling. We don't want to see a circular economy that recirculates these chemicals all over, and then yeah, and then we want to see finally that, you know, ideally that this treaty is a bit more systematic in getting rid of problematic chemicals. So going from a chemical by chemical approach that we have seen in most chemical legislation in Europe, in the US, in Canada, and in those few countries that actually do regulate chemicals, going to a, you know, class-based approach, or just getting rid of all hazardous chemicals. So to have like a toxic-free future and plastics that are less harmful to our health. Thank you very much for your attention, and I look forward to the Q&A.
Thank you. That was really interesting. All right. So if you can type your questions in, we may end up going over a little bit because we have supposedly 2 minutes left. But so in the chat, I just want to mention that Jitka's been sharing links to some of the reports, and we're also going to put those on the web page for the webinar, so that if you're listening to the recording after this, they will be there. Okay, so there's a couple questions. So I'm going to start with the top. To Vito, lots of mentioning of microplastics. What about nanoplastics, as those are the ones in rain and air, like in the air?
So very quickly, there is no exclusion from the scope of what is problematic. What I am thinking is that the fact that there is a plastic treaty being discussed will also attract a lot of funding in academia and for more research on the harm of these plastics, and so it will give like an opportunity for researchers to showcase more what are the negative health and environmental impact of microplastic going down to the nanoscale. And there is obviously this opening to, you know, plastics harms in all environments, and that would include also the impacts on air. But more than that, I cannot say.
All right, I'm going to keep sticking with you for a minute here, because some of these are for you. Is there a differentiation between incineration, landfilling, and global waste dumping? This person says that modern thermal treatment has been able to address many of the concerns of pollution, I think, by incineration, but landfilling has not, and not dumping either.
Maybe I think Jitka is better positioned to answer this question.
Mhm.
I don't
Mhm.
think that incineration has been really able to address these issues as far as we know. But Jitka, maybe I'll leave it to you. That you're...
Yeah, yeah. Unfortunately, it was not, because once we have chlorine or bromine content in our chemical, in our polymeric structures, they are often chlorinated or brominated dioxins being formed in thermal processes. So even though we have, in simple words, good filters, it's not only about filters, but a good system for cleaning the after incineration residues, then we have a lot of fly ashes remaining after the incineration processes. And in those fly ashes, there are all the persistent organic pollutants, including dioxins, brominated flame retardants, and many more chemicals being concentrated. And with those fly ashes, they also end up in some landfills, or in some cases, they are even used in some construction processes and can continue to leak the environment. So no, I'm afraid that incineration is not the way.
Yeah, I was wondering about that too. Okay. Also, Jitka, from your research on the approach to environmental chemicals in various countries, is there a particular country or legislation that might be inspiring to the EU or the US approach to chemical pollutants?
We are quite lucky and happy to see that there are 5 countries in the EU currently proposing class restriction for entire PFAS group. Yeah, so it's currently going on in the EU. How to see the results and the end of this, or maybe rather next year, but this is definitely a step forward which would love to see, because with this we might see really precedent change of thinking in chemical legislation using the class-based approach. So we hope to continue in this line. Yeah.
All right, more on the regulation. How do extended producer responsibility regulations fit in with the treaty concept and timeline? And should the EPR bills be more focused on toxicity than reuse of plastics?
That's a good question. Definitely, extended producer responsibility is something that, which means like basically giving the producer responsibility for the entire life cycle of a product. It is definitely something that many countries are looking at, also as a consequence of the increase of these regulations of plastics. It is questionable if extended producer responsibility has brought in many cases like a reduction of the harms from these products. If we look at electronics, that has been one of those cases where there has been a extended producer responsibility legislation, but it probably didn't work. But definitely it should be focused on also the design of the product. So it really depends on the outcome. If it's more focused on the toxicity also of the product, it has like a better chance of also decreasing those problematics, those problems that we have at the end of life. And in the end, these, making a producer pay is an incentive, as long as they pay a high enough fee that would disincentive them from putting on the market plastics that are toxic.
So I'm going to ask 3 related questions to each other. How do you know if a product contains toxics? How do you find BPA-free baby bottles? And do you know if there's any funding sources that can help consumers purchase more sustainable substitutes, or business incubators that are actively promoting new product development? So like consumer?
Yeah, it's very difficult actually from consumer end, because there is no simple clue for consumers to really decide for toxic free products. It's why we work with the governments and with international treaty negotiators to ban those chemicals from the end of the legislators, and not to entrench them and make the polluters responsible. And basically this is the approach, because sure there can be some indication helping consumer to find toxic free products. There are some certifications and labeling which we may trust to. There are maybe some simple methods how to identify problematic plastics, but no one simple clue for that. So more for us to work on a polluter end of the problem. Yeah.
Yeah, if I just very quickly, I can only say that we would like to see more systematic approaches, like not to put into the consumer hands the response to these problems. And the big issue also that we have found with with these bisphenol A free is that often the substitutes end up being like regrettable substitutes of BPA. So I don't have a silver bullet there, but it's more like asking at least, as a very least, transparency. Like the EU has some relatively good laws that where consumers can ask the chemical content of some priority hazardous chemicals. In the EU, is substance of very high concern, but that is not the case in most other countries, and so it is very difficult to get that information without an obligation for transparency, which companies don't want, because transparency costs money for them.
And then a couple of people are wondering about plastics and petroleum and climate change, and for example, to what extent is plastics problem inextricably tied to our dependence on petroleum and chemical engineering in sectors where they are unnecessary but profitable? Would these approaches be continued at this scale if petroleum was no longer as readily available?
Jitka, do you want to try on this? I mean, obviously, it is reported that there was a recent recently the CEO of Total, which is like the French petrol, like the state petrol company, saying that plastics are a great resource for companies that work in the field of fossil fuels, because it's going to be a way for them to use those fossil fuels and keep on being profitable. I'm based in Canada, and I've seen in the last few years the government subsidizing like with hundreds of millions of Canadian dollars, like the plastic industry, so that there could be a transition from burning fossil fuels to making single-use plastics. And so that is going to happen more. Like if we start to keep it in the ground, that is going to be the groundbreaking moment, because as some expert on material science know that, like all our plastic economy and chemical economy is based on like 7 basic chemicals that are derived from fossil fuels. And if we want to make real innovation, we need to move away from that for materials that are less persistent, more biodegradable, and less energy intensive. So yeah, it is like a part of the same problems around fossil fuels.
And then I think real quick, so do we know how the components of the treaty will be defined, like focusing on plastic products or the components inside of the products?
That is something we don't know. I mean, that is it is unclear how it's going to look like. I mean, there's clearly going to be some national action plans where the possibly the quantity of plastics that are produced are going to be tracked, and some targets, hopefully for reduction, for phase out, are going to be set. But it's a completely open battleground. Like, you're now hearing the perspective from civil society that is looking for, you know, decreasing the public health impacts of plastics. If you hear you know, what the American Chemistry Council has to say, their perspective is, let's burn more plastics and let's avoid that the plastic get to the sea, but nothing about changing business model or anything like that. But you know, like having shortcuts. So that is really going to be again the battleground. Like, so we're very excited about the fact that the problem has been recognized, but how it is going to be solved is going to be still, we're still far from getting there.
And then one more, what do we do with the plastics that are already out there? Like, I mean, the idea is to reduce the production, but also if people are thinking that recycling will solve the problem, anyway, but if they're already produced.
Some of them are possible to be recycled. I believe so, yeah. They are safer plastics such as polyethylene or polypropylene, but there are many problematic materials with toxic additives which shouldn't be basically being circulated, especially when we talk about persistent organic pollutants, right? So there is no way to continue their use in recycled products. Yeah, so recycling of some of them for those containing POPs, there are destruction technologies available to destruct POPs. To POPs in plastics and other waste materials, so definitely apply such technologies which do not emit any unintentionally produced POPs into the environment. Yeah, but
All
not
right.
simple question.
Anyway, thank you. I think we're good now. I think we got pretty much everyone. So thanks a lot for staying extra. I'll turn it over to Hannah.
Great. Yeah, thank you so much. We're coming close to the end of our webinar. I really appreciate these talks. Fantastic. And thank you for all of your work and also shedding light on the inequities of plastic and the burden they bear on societies and communities that don't have a lot of say. Anyway, so we're approaching the end of today's webinar. A video recording will be available on CHE's website soon, and tomorrow you'll receive an email containing a link to the video. The next CHE Partnership webinar will take place on May 12th and is titled Personal Care Product Use and Chemical Exposures Among Black, Latina, and Vietnamese Women in California. Findings from the Capable Project can be found on our website. Check it out. To learn more into RSVP, please visit our website at healthandenvironment.org. If you are new to CHE and would like to stay updated about upcoming events or more, please sign up to receive our newsletter by selecting the Join Us tab at the top of any page on our website at healthandenvironment.org. Additionally, if you appreciate these CHE webinars bringing the latest environmental health research for free, we encourage you to support CHE's ongoing work by making a tax-deductible donation via our secure website. Again, our website is healthandenvironment.org. With that, I would like to thank our speakers, Jitka and Vito. It's a pleasure working with you. Thank you for taking your time today to share with us your research and work. And Sarah, thank you for moderating. It was excellent. All right, wishing everybody much health and wellness, and thank you for joining us.